It is becoming increasingly common and popular to implement optical flame detection technology in large commercial and military aircraft hangars. The Unified Facilities Criteria, or the UFC, for U.S. military hangars requires the use of optical flame detection in the hangars, and the new revision that they're working on for NFPA 409, which deals with fire protection and detection in aircraft hangars, is likely to include recommendations or requirements for optical flame detection. The reason why we're seeing optical flame detection take over or start to supplement and complement traditional flame detection technologies like smoke and heat detection is that it offers a number of very nice advantages over the traditional technologies. The first and probably the most important of these is response time. The reason why we see this is that you're usually going to have a pool fire or something at the deck of the hangar. And for the smoke detector or the heat detector to go into alarm and to function, the physical signs of the fire have to reach the detector, which is usually going to be on the ceiling of the hangar. And that could be a 10 meter, a 20 meter, or a 25 meter high ceiling, depending on the size of the hangar that you're dealing with. And if you then, on top of everything else, have thermal stratification in the hangar, which causes a greater delay in the smoke or the heat reaching your level of the ceiling, then you could have several minutes between the time when the fire starts and when you actually get an alarm. By that time, you're likely to have a very large fire, and it's been shown in some studies that if there is a fire in an aircraft hangar, the aircraft may begin to take substantial damage from the fire within about 45 seconds. A lot of these high-end hangars can have high expansion foam systems that can fill the hangar and put out any fire in the hangar within 2 to 2.5 minutes. But if your aircraft can take damage in 45 seconds and it takes 2, 3, 5 minutes or longer before your smoke or your heat detector goes into alarm, how much good does that foam system really do you at that point? Whereas with the optical flame detectors, you have a device that the alarm can happen within 5 to 10 seconds. You get much faster alarm response. And the reason for this is that the sign of the fire that the flame detector is looking for is the light from the fire, and that light travels at the speed of light to the detector, allowing for rapid detection and response. The other issue that you're going to run into here is with device count and with maintenance issues. Because with the optical flame detectors, because they can respond to a relatively small, usually 1 foot by 1 foot fire at distances of 150 to 200 feet, you can have one detector providing coverage to a relatively large area of your floor, of your hangar. Whereas with traditional smoke and heat detectors, you're going to have a two-dimensional grid of detectors covering the entire ceiling, and you might have a very large number of detectors. You could be looking at dozens of smoke detectors or heat detectors or dozens of sprinkler heads that need to go off versus just maybe 6 to 12 optical flame detectors, depending on the size of the hangar and what kind of hangar or what kind of detector you're using and the settings that you're using. So your device count can be much smaller with the optical flame detectors, and your maintenance can be a lot simpler. And I point this out because if you have a smoke detector or a sprinkler head or a heat detector that's up at the ceiling at 20 meters up, you have to periodically check that thing and make sure it's working right and make sure that it's functioning properly, and you have to do maintenance, and you have to periodically replace those things. If you have to get up to a 20-meter high ceiling, that's going to be quite a task. Whereas with the optical flame detectors, these things can be mounted usually 2 to 4 meters up the wall so that they don't get blocked easily. And you can easily test them using simple test candles. You can just get a simple short ladder to go up and either take them off their mounting position or run quick diagnostic checks on them or clean their faceplate. And it is just profoundly easier to test and inspect and maintain 6 to 12 optical flame detectors than it is potentially 100 or more smoke detectors, or checking for problems with a smaller number of, say, aspirated smoke detectors in a hangar facility like this with a very high ceiling. All of that is not to say that there are not challenges or issues that you have to overcome in this application with optical flame detectors. This is one of, if not the single most challenging application for optical flame detection that I have personally experienced in my career, because it combines a number of very sticky challenges for the detectors. And we're going to get into that in just a minute.